Hey friends, it's fall, so that means Halloween is coming up, and I'm going to show you how you can harness the power of a physical reaction or a chemical reaction and create some really low budget and really great decorations. Of course, I'm kidding because these are not going to look awesome, but we are going to look at the difference of a physical reaction and a chemical reaction. Both of these are going to yield or release or give off carbon dioxide gas. And we're going to look at these two different reactions and how they are different but similar.
How does a tree grow? Why does the wind blow? When does a flower bloom? How can a rocket shoot to the stars or land up on the moon? It's science and technology, engineering, mathematics. Get smart, keep it simple. Let's learn about STEM.
Before we get into today's video, I want to read a quote from Disrespectful Housefly. He says, "Sorry for being so annoying and messing up your video." I appreciate you owning up to that, Mr. Housefly. You were quite a nuisance, and I appreciate and accept your apology. Let's get into that video now. The first reaction we're going to look at is a chemical reaction between vinegar or an acetic acid solution, it's acetic acid and water, and baking soda or a base. So this is going to be an acid-base reaction. I'm going to take this little vase and I've got some vinegar or my acetic acid. And in the spirit of Halloween, we're going to make it green like slime. So when we mix this acid with our baking soda base, it's going to neutralize. It's going to give us a water and a salt, and it's also going to release carbon dioxide gas. So when you see the bubbles, the gas that's filling those bubbles is going to be carbon dioxide. You also, if you've ever used vinegar in your kitchen, it smells not good, and it like burns your nose a little bit. After this reaction, of course, y'all aren't going to be able to smell it, but it neutralizes that odor too, so you're not going to get that strong vinegar smell. So this is a chemical reaction. That means that it changes. They're going to rearrange their molecules, the core of what makes them sodium bicarbonate and acetic acid. Those molecules are going to rearrange and become water and salt and gas. So there is actual change in the molecular structure of these chemicals and these compounds. So we're going to dump this here.
Chemical reaction.
So how cool is that? So that is a chemical reaction. What went in did not come out. It changed. So what you put in got rearranged and it created something new. That's a chemical reaction. Now let's look at a physical reaction. I quickly grabbed a sheet of aluminum foil to show one type of physical reaction. The aluminum foil stays aluminum foil, so it's not going to become something different, but its shape can change. So if you crumple it up like this, it had a physical change. So its shape is different. It's all bunched up now. That's a physical reaction. That's a physical change. To look at a more fun physical reaction, we're going to do an experiment with Diet Coke. In your Cokes, your carbonated beverages, whatever you like to drink, sparkling water, whatever, that is carbon dioxide gas that they have pressurized so much and pushed into your drink that those carbon dioxide gas molecules have liquefied. They've shrunk down. They're so tight, they're liquefied now. They are held together, or they're held by the water. They're like trapped in here by the water. So if you stir or shake or something, it breaks the bonds between the carbon dioxide and the water, and that carbon dioxide can expand and release. What we can do using Mentos, the Mentos have a surface roughness. So everything has a surface roughness. Some things are smoother than others. So like, the granite countertops or the side of this glass are pretty smooth. This pumpkin, it's rough. Everything has a surface roughness. These Mentos, if you took a microscope and looked really close at them, they're really rough. Something about the roughness of these really does an effective job of breaking those bonds between the carbon dioxide and the water molecules without changing them. It just breaks those apart where they're kind of holding on to each other, and that CO2 or that carbon dioxide gas can release. And if you release it quickly enough, it overflows and that carbon dioxide gas escapes very quickly. So we performed a chemical reaction here and released carbon dioxide gas. Now we're going to perform a physical reaction here, but we're also going to yield carbon dioxide gas. So I'm going to open this, and when I open it, you'll hear some of that gas go ahead and release. And you see some of the bubbles starting to come up already. I am going to do, I haven't done this in this setting. We're going to start with one and see how that goes. No, let's not be lame. Let's see if I can get 3 in there pretty quickly, okay? I should have made a little funnel, but 1, 2, 3. So that released some carbon dioxide gas. Okay, and then we've got, oh my God, that was so much worse than I thought it was going to be. Some of the soda came out with it because those bubbles pushed some of the soda out. But you've still got soda and you still have your carbonation or your CO2. Nothing changed. It just kind of moved around and released. I'm going to clean this up. Give me just a second. Now what I thought would be fun to do is compare these two reactions and see which one is more effective at blowing up a balloon.
Work it out. Power Hour.
I'm going to kind of stretch these out, get these ready, and we're going to fill one balloon with baking soda and put Mentos in the other balloon. The trick will be making sure they come out of the neck of the balloon. Okay, so I got Mentos in there. I'm going to put baking soda in here. Okay, so I got baking soda in here, Mentos in here, and I'm going to pour some vinegar in this bottle. Okay. I want to make sure there's like no neck of that balloon, or else I know the Mentos won't go down. Okay, so let's see, which one do we think will blow the balloon up a little more effectively? I have no idea. So let's just see. We'll do one at a time. This is our chemical reaction. Woo! Okay. Pretty good. And we'll see if we can get these Mentos to go in this Coke. Yes. And the Coke, even the vinegar and the baking soda, it like came into the balloon a little bit. Oh my goodness. That's going crazy. I can't believe it's not blowing up any more than that. I'm actually pretty surprised by that. Because this reaction seemed a little bit bigger. But this one filled up the balloon better. Let's try it one more time. And I'm going to actually pour out some Diet Coke. So now it's under the label. Let's see if we can do that again. I'm going to use the same amount of Mentos. We only want to change one thing at a time. So we've changed the amount of liquid in our bottle. I don't want to change the amount of Mentos either. What did I say? I don't want to change the amount of Mentos too. Did I say either? I don't know what I'm saying. Okay. Ah! So we've got 3 Mentos in our balloon. We want to keep the Mentos as our control group. So we don't want to change that. We did 3 Mentos and a full bottle of Diet Coke, or a full little bottle of Diet Coke. Now we're going to do 3 Mentos again, but this one is about halfway full. For science. It also has a little bit less of a neck than that one. But we'll see. Let's see what happens. Okay. Put this one over here. Put you right here. 1, 2, 3. I think I've got so much of the neck on it. Well, there you have it. The chemical reaction of the baking soda and the vinegar was much more effective at blowing up the balloon than either of the Cokes. This is just this poor balloon. It looks so sad. I'm sorry I embarrassed you. So sorry. But we have a winner. Our winner is baking soda and vinegar to blow up a balloon. And like I said, you know, times are hard. If you're needing an easy, fun way to decorate for the holidays, for Halloween, you know, grab you some jack-o'-lantern balloons and have at it. Perform yourself a chemical reaction between vinegar and baking soda, and you can decorate. Thanks so much for watching. I hope you learned something about chemical versus physical reactions. I hope you had fun doing some science experiments with me. I hope you enjoyed the company of our balloon buddies. And as always, we're gonna get smart, keep it simple, and learn about STEM here. Hope you had fun. Bye! Thanks so much for watching. I hope you enjoyed this video. Be sure to like and subscribe to our channel so you know when new videos come out. And here are some more videos you might enjoy. Bye!